In this video, we're going to look at the relationship between sine and cosine. So the first thing I want to do is look at this example and go ahead and come up with the sine and cosine for angle A. So using SOHCAHTOA, if we're looking at angle A in this picture, the side opposite angle A is going to be lowercase a. The side adjacent to A will be B. And then across from the right angle is the hypotenuse. So if I'm trying to find sine, that's so it's going to be sine of A is going to be the opposite, so A over the hypotenuse, so A over C. And then cosine of A is going to equal adjacent, so B over C, adjacent over hypotenuse. And then if we do the same thing, but now for angle B, so now when I look at angle B, the opposite side is now side B, and the adjacent side is now side A. So that means if I go to write sine of angle B, that's going to be the opposite, so B over the hypotenuse, which is C. And if I look at cosine of B, that's going to be the adjacent, so A over the hypotenuse. So now hopefully you're seeing a connection here where sine of A is equal to cosine of B. And the same thing goes for cosine A and sine B. So what this means is sine and cosine are going to be equal whenever the angles that we're taking them of are complementary. Because if you look at A and B are two acute angles in a right triangle. So if angle C is 90 degrees, well, that means you have 90 degrees left to split between angles A and B, which means they have to add up to 90, so therefore they're complementary. So the only time that cosine and sine will be equal is if the two angles are complementary, if the two angles add to 90. And the reason for that is because the only difference in our ratio is the opposite and the adjacent. So if you're looking at angle B, well, the opposite of angle B is the adjacent to angle A. And since those are the only differences, well, between sine and cosine, if you're looking at the opposite of one and it's the adjacent of the other, that's why they end up being the same. So sine and cosine of complementary angles will always be the same. And it's all because the only difference between the ratios is the adjacent and the hypotenuse, or the adjacent and the opposite. And when you're looking at your picture, if you're talking about angle A, the opposite of angle A is the adjacent to angle B. So that's why if you're switching the angles, you're switching the opposite and the adjacent as well. So do you notice relationship between any of the trig ratios? Yes. Let's go ahead and just write what we just basically said. So sine of A is equal to cosine of B, and sine of B is equal to cosine of A. And this is because the measure of angle A is complementary to angle B. So that's the rule here. And these are called cofunctions because of this. So sine and cosine are going to be equal whenever you're taking them of complementary angles. So if we look here, that's basically what I just said, but you might want to just highlight this or mark it. Here is the idea. So the sine of an acute angle is equal to the cosine of its complement, and the same thing goes the other direction. So how do we use this to solve problems? So the first problem here is finding the value for theta when sine and cosine are equal. Well, the only time that sine and cosine are going to be equal is if these two angles are complementary. So if those two angles add to 90. So these angles must add to 90. So all we have to do, theta plus 15 equals 90. Just solve for theta, so subtract 15 from both sides, and you get 75 degrees. So that's it. So to fill in the blanks here, again, since we're talking about sine and cosine being equal, these two angles have to add to 90 for all of these. So the only time that sine and cosine are equal is if the angles are complementary. So 90 minus 42 gives me 48. So this one has to be 48. 90 minus 12 gives me 78. And then the last one, 90 minus 45, gives me 45. And you can verify this by just typing these values into your calculator. If you type sine of 42 in your calculator, and then you type cosine of 48 in your calculator, you will get the same decimals. And it's all because of this complements theorem. And then the last one here is now with algebraic expression. So instead of just being able to say 90 minus the one angle, I actually have to set up an equation. So again, sine and cosine are equal, which means that these angles have to be complementary. So they're not equal to each other necessarily. We saw the example where we had 45 and 45, but really all we care about them is being complementary. So whenever sine and cosine are equal, it means that the angles have to add to 90. So to solve these three problems, I'm just going to take these expressions, so 3/4 times x plus 1/4 times x equals 90. I'm just adding them up to 90. So for this one, you could multiply everything by 4 to clear out the denominators, but if you just look at this, if you're taking 3/4 and you're adding a fourth to it, that's going to equal 1 whole. So this is really just 1 when you combine those, or just say x equals 90. So you don't even have to really solve much of that. You could multiply by 4 and clear it, but it's easier just to think of it as a whole number. Next one, same concept. Take the angles, add them up, set it equal to 90, because if sine and cosine are equal, well then those angles had to be complementary. So then we just combine like terms, so we get 6x minus 32 equals 90. Add the 32 to both sides, you get 122. Divide by 6, and we get a fraction, so I'm just going to leave it as a fraction here. So I'm going to just leave it as 61/3. And then the last one, same concept, so 3/4 x minus 3 plus 66 has to equal 90. And the first thing I want to do is combine my like terms. So I have plus 63 when I combine those. And then go ahead and I would just subtract the 63 over. If you really wanted to, you could multiply everything by 4 to clear that fraction, but I would get the fraction by itself first since we're just dealing with a number on the other side. So subtract the 63, you end up with 27. And then you could multiply by 4, then divide by 3. You can multiply by the reciprocal of this by 4/3 to cancel it out. You could also just divide by 3/4. So lots of different ways to find your x value, and in the end you get x equals 36. So there you have it with your new rule or new theorem here, is that sine and cosine are equal whenever the angles are complementary. So sine and cosine of complementary angles are equal to each other. So write your key ideas down and do your check your understanding problems, and we will talk about those in class tomorrow.